This is a sketch I drew of my layout. It doesn't make a lot of sense really until we start to put some buildings on it. And so to put the thing in context, I have an engine shed down in the bottom right, a little village station, Dottisford, and the main station, which is Briceborough. There is a turntable, a bit of a goods yard here, and the opportunity to run trains round in various ways, but it's a bit limited on this section here where it's just a single track. So that's the layout as it stands. Now this shows all the brakes that I'm going to put in to make all the blocks. The node it refers to is the MERG node, and in fact node 300 is connected already, and I've got the lower section of this layout working. The top section, which is much more complicated, I've yet to do, and so that will be a bit of a learning curve as I make this video. Just to complete the picture, I'll add the point numbers that we allocated to CBUS, and you remember we used a couple of those down at the bottom here, points 13 and 14, to animate in part 2 of this series. And I'll also put in here the block numbers that I've allocated. Now blocks can be any length you like, but I quite like to have quite a number of shorter blocks so I can actually see where the train is. If you have long blocks, then the block simply highlights to say that the train's on there somewhere. I like to see it swapping and changing as the train moves along. Each block can contain one point, but not two, because things start to get really complicated then. And as you can see, all the points here have got their own numbers and are associated with either their own block or an adjacent block. Now this is a MERG DTC2. DTC2 because it's got 2 track sensors on it. Now when you're connecting to the track, you only need to break one side, one rail, and make sure that's always the same rail, just for convenience. In my case, I've used the rail that's nearest the centre of the room, put a cut in them, and then filled that cut with some sort of filler just to prevent anything else getting in the way and remaking the contact. So either side of that break will come to a track sensor. Now you can see here that these two are connected together because that's the power coming into the track from the DCC controller. It then passes through these 2 rather large coils to 2 separate blocks on the layout. So what happens in the sensor is that as soon as it senses any current drawn by a locomotive or a coach or a wagon or something else that's on the track, then that current passes through this coil. That's sensed by the chip and it produces an output on one of these pins. Now these 4 pins at the back here are, the outer 2 are for 5 volts power and the inner 2 are the digital on or off outputs from the sensors. So the binary digital outputs from those 2 sensors now need to go to something that will generate a code to go along to the CBUS when something appears on the track. The board I've chosen to do that with is a CAN-V input board. It has 16 inputs, but I'm going to use just 8 of those for sensing the blocks on the railway, because I'm going to use the other half of the CAN-V input for other types of sensors. Right, so first of all, what you see here is the CAN-V board, and what I've done is just connect a piece of wire to the 0 volts end of the connector, and now all I'm going to do is plug it into the CBUS. Now as you can see there, we've got a power LED, which in this case is bright blue, and a yellow LED which says it's in FLIM mode. This particular PCB doesn't work in slim, so that's fine by me. I need it flim mode anyway. So the next thing to do is to produce some events. Now what you can see on my computer screen, this is actually the second one of these I've done. The first one was a real experiment. This one is hopefully going to work. So if you look at this section here in the top left, you'll see that I've got one module here which is marked block sensors. It's showing as a CAN-MIO, but it's actually a CAN-MIO in the guise of a CAN-V-INP input module. So first thing to do is, now I've plugged it in, is to make sure that the FCU finds it. So we press the little button, hold it for a while, okay, so I've now turned the flim off. As you can see, the yellow LED's gone out. Hold my finger on the button till it comes back in again. There it is. And now it's coming up and asking me for a node number. Now, as I say, this is the second one I've done. The first one I called node 300, so this one I'm going to call 301. So I'll type in 301 there, and a node name, I'll call it block sensors 2. Press OK. So now we've got showing up in here on the screen block sensors 2. Now if I click on that, there's nothing in it, there's no events. So the first thing we have to do is generate some events, and it's ever so easy with these. All you do is, with that lead I connected to 0, we then link the other end of it to the various inputs. Now on the board, input 101 is shown here, input 1, so if I short that to 0, I get an event, event 1. So all I'm going to do now is run down here and do them all. 102, 3, 4, 5, 6, 7, 8. And then on the other board down here, on the other connector rather, we've got 9, 10, 11, 12, 13, 14, 15, 16. So we've now got 16 events generated on this board. Next thing to do is to rename them. Since each one of those inputs is going to be connected to a Merg sensor, then I'll rename them MS1 to whatever. Now in fact, my first board did the first 16, so I'm going to start actually by calling this, because of the layout of the boards and things, I'm going to start with MS20. So here we go then, event 1, right click on there, edit name, and we'll do it in capitals, MS20. OK. Edit name. So we've got them all named out from MS20 through to MS33. What we haven't done on here, of course, yet is, what I should have done when I first plugged it in, was read the properties, see what it is, and also read the NVs. There we go. So now the node is a part of the layout.